Generators, power stations, and alternators all produce AC sine waves. The generation of AC and hence AC waves is primarily done by an AC generator as shown. Motion results in a coil rotating within a magnetic field. As a result, a current is induced within the coil. This current is alternating as shown in the GIF, as a result of the commutators and bushes placed on the generator. Both current and voltage generated in this way have an AC waveform, as the current is moving in and out backwards and forwards. Same as with the voltage, as it is just the potential difference, and without voltage there would be no current. From an engineering aspect, AC sine waves are crucial when using AC current and AC voltage. AC sine waves give a mathematical representation of this AC current and AC voltage and are used extensively throughout electrical engineering. AC waves are used within power transmission as they can easily be stepped up, stepped down, and the frequency modulated for certain uses. AC waves are used in surveying, navigation, and astronomy as the red and blue shift show movement of the object. AC waves are also used in music for their transmission as the amplitude and frequency can be modulated in order to transmit sound. GPS and mobile phones rely on triangulation in order to get position coordinates using the satellites and interference patterns. Finally, like music, TV also uses the modulation of sine waves in order to transmit images and footage. A sine wave is a smooth, repetitive oscillation that continues over time, or in our case, it will continue over time. The x-axis will be time, the y-axis will be voltage or current. First off, we have the maximum values or peaks. These are the points pointed to on the graph. The highest maximum value of this graph is 1. The minimum values are referred to as the troughs of the curve. The trough of this curve, or the minimum value, is -1. Peak-to-peak voltage is often referred to within electrical engineering. Now the peak-to-peak of this graph is 2. As we can see, we have our maximum value plus the absolute value of our minimum value. The amplitude is the distance from the x-axis to the maximum point on the graph, as shown by the blue arrow. The blue line on the graph represents the average value of the graph. This is the midpoint between the maximum and minimum values. On this graph, the average value is 0. The period of the sine wave is the distance that it takes for the sine wave to complete one full oscillation. Now for this graph, the period is approximately 6.25. Finally, the phase shift is when the whole graph is moved along the x-axis in either a positive or negative direction. Now, a positive phase shift would be the introduction of a negative integer within the sine function, and vice versa. The period is equal to 1 over the frequency. Period is referred to as t and is in seconds. Frequency is in hertz, or oscillations per second. The basic formula for a sine wave is as shown below. A is the amplitude. As A is increased, the amplitude or voltage or current is also increased. That is the peak voltage or current. If A is negative, the graph first starts off going in the negative direction. It is still the same sine graph. 2 pi is a constant, t is your x-axis, and the frequency of the wave is to be calculated from the period. The final element of the sine formula is phi. This is a phase shift relative to t equals 0. If the value is negative, then the graph is shifted to the right. If the value is positive, the graph is shifted to the left.